seems like mic is detected. We should just start broadcasting, including this kind of trouble.
But we will cut this part out when publish this video on YouTube.
After we'll cut.
So are you gonna click the go live button?
I already clicked that.
Okay.
So we are having trouble with one of the speaker's microphone. So we are trying to solve this at this stage. I don't see the stream actually. Trin, have you started broadcasting? Okay.
You clicked it.
Now I can see it.
Yeah, there is a little bit later.
Yeah. So what should we do? If now we can hear you. Great, congratulations.
Sorry, I had a computer problem. I changed another computer. Sorry.
Okay.
It's okay now.
Yeah. Do you think you can share the slides without any problem, or maybe we can try
because
later.
I just changed a new computer. I need to copy the slides.
Yeah.
Okay.
Yeah.
Sorry.
Yeah.
But we are planning to go from Kaz in the beginning, right, Julian?
Yes. Yeah. So
that's correct.
Okay.
Just try. Yeah, we just want to see if the slides works properly. So just try to share and let us see.
Yeah, I think it's okay. So yeah, Julian, I'll leave it to you.
Okay, thank you. So welcome everybody to the final consciousness talks of 2021. So this is number 13. So the Asia Pacific Consciousness Network are very proud to welcome two speakers again with us today. So the first will be Kazuhisa Shibata and also Shunfang Fu, who'll be talking to us both about the interesting relationship between consciousness and learning. So the format today is going to be the same format that we typically have for consciousness talks. The typical format here, where each speaker has half an hour, the first 15 minutes for speaking, the next for some questions, and then we'll switch over to our second speaker. And then for the final half hour, we'll have some group discussion, catching up on some of the great topics that come up in the talk. So our first speaker today, we'll move here, is we're very happy to welcome Shibata Sensei, my boss. He's the team leader of the Lab for Human Cognition and Learning here at RIKEN Center for Brain Science in Wako, Japan. Shibata Sensei is a neuroscientist with expertise in visual perception, perceptual learning, neurofeedback in fMRI, many different topics. Look for his recent chapter in the literal textbook on decoded neurofeedback in fMRI. So today he'll be talking about perceptual learning and particularly the roles of attention and consciousness in perceptual learning. So I'll pass it over to you, Kaz. Thank you very much. And yeah, looking forward to it.
Thank you for great introduction, Julian. So the title is the role of attention and consciousness in perceptual learning, but I mostly will talk about attention and the reward. And then the consciousness is actually the open question. Because the previous studies controlled attention and consciousness at the same time, so that without any separated manner. So let me talk about these experiments. So what is perceptual learning? So the perceptual learning is defined by, this time the visual perceptual learning, VPL, is defined as the long-term increase in visual performance as a result of visual experience. So it's very broad definition here. So let me explain a little bit. So let's assume that you are asked to discriminate the motion direction of the randomly moving dots on the bottom. So the leftmost is the coherence is just 5%. It's really hard to see the direction, left or right. And in this case, without any training, your performance is almost chance level. It's sub-threshold and subliminal. But if it is like a 20%, it's clearly clear to see. I don't know that Zoom allows you to see this, but basically it's easy to see. So your performance would be decent, about 90% or 100%. And 10% probably your performance is left or right, and then 60 or 70%, which is very hard. However, after being trained on this task for like 10 days, your performance will be greatly increased like this. So now the previously very difficult task, 10%, becomes a relatively easier one. So the sub-threshold is still sub-threshold. So that this kind of the experience-dependent increase in the visual performance is defined as visual perceptual learning. So here's the one big question. So how do we know what to learn? So the visual system needs to be plastic to allow for visual perceptual learning of the new and important stimulus. However, it also needs to protect existing visual perceptual learning from being destroyed. So it needs to be plastic as well as stable. So here is the plasticity stability, so-called plasticity stability dilemma. And we did not know how to solve it. And a series of psychophysical experiments proposed several interesting solutions. So first one is attention. Let's say so that you keep fixating on the center, and you are asked to attend the left side stimulus and do some task on the left. At the same time, so that another stimulus is constantly presented on your right, but you ignore that. So in the frequency of the presentation, these two stimuli are the same. However, one is attended, the other is not attended. So in that case, visual perceptual learning occurs on the left stimulus, but not on the right stimulus. So looks like the dilemma is solved. So attention enables visual perceptual learning of task relevant and possibly important stimuli, while the attention prevents VPL of task irrelevant and probably unimportant stimuli. So attention can reconcile plasticity and stability. So looks like the best solution for PS dilemma. So looks like solved. However, there is a problem. So under the task relevant learning framework, so that we only learn what we think to be important. So how can we learn what we are unaware of its importance? So to solve this, there is some need for task irrelevant BPL. And from 2001, so Dr. Takeo Watanabe and Yuka Sasaki, who was in Boston University and now in Brown University, where I did the postdoc training. So under them, their supervision. So they provided many interesting evidence about task irrelevant visual perceptual learning. So let me show you the very first experiment. So before and after the perceptual learning training, so subjects were asked to discriminate the motion direction of the randomly moving dots. So the coherence was 5% and 10%. 5% is completely sub-threshold. So with your maximum effort, you can clearly tell left from right. For 10%, your performance would be the supra threshold. It's supra threshold, so your performance would be like 60 or 70%. So this is pre and post test of your visual sensitivity. And in the middle, so there is a training period. During this exposure stage, subliminal motion was constantly presented. However, you did not attend to that motion. That is completely task relevant and just exposed. Your task is the RSVP task on the phobia. So you are asked to detect the gray characters among the stream of the black characters. This is an extremely difficult task. So your attention is attracted to this difficult task. And the random dot motion is completely task relevant and also subliminal. That means even when you fully attended to the motion directions, you cannot tell. So in two meanings, so that it's really hard to see. However, the visual perceptual running occurred specifically to the exposed direction, but not the unexposed direction. So this means the VPL specific to the exposed direction, so the task relevant VPL occurred. So it's really weird. So the earlier study says, okay, attention is gating perceptual running, but now attention is not necessary. So what happens? So later on, they found the very interesting phenomenon. So they found that this task irrelevant perceptual running occurred only when the motion direction was paired with task target. So now on the upper figure, so the four directions were presented in the same frequency. However, upper direction was always paired with the task target. In that case, the visual perceptual running occurred only for the upper direction. So it's not purely passive. So they interpreted this as a task relevant perceptual running occurred when motion was paired with internal reinforcement signals. So the task target is here, then when task target is here, everything is learned in front of you. So that was about task performance. However, later on, they developed a very interesting experiment as well, again. So now, they hypothesized that the perceptual running of the particular stimulus occurs when that is just paired with a reward. So subjects were deprived for the 5 hours prior to the experiment. So the no food or no water 5 hours prior to the experiment in the daily session. So 20 days. It's crazy experiment. And task is nothing. So they were just asked to fixate on the center. And on the left side, so the nows invented. So the continuous flash suppression was happening. So on the left eye, so colorful Mondrian patch was presented on the right eye. So the Gabor patch, weak Gabor patch was presented occasionally. Sometimes on the like vertical, sometimes horizontal. And only when vertical orientation was presented, so they got some small water reward. So subject has no idea what is happening. So their percept is always like this. And occasionally they got the water drops. And in this situation, task irrelevant visual perceptual running occurred when orientation was paired with water reward. And when they were not deprived for the water or food, no perceptual running occurred. So clearly, so this is due to the pairing of the orientation and reward. And there's no consciousness of the orientation. And no, of course, no attention to orientation. So, sorry. Task irrelevant VPL occurred when task irrelevant stimuli are paired with task target or reward. And later on, so I don't really describe here, but task relevant VPL occurred when stimulus evoked brain activation patterns are paired with reward. And so it looks like of course the task relevant VPL is facilitated by reinforcement signals or reward. So it seems like the reward facilitates both task relevant and task irrelevant VPL. So now we go back to the attention question. So the reward facilitates everything, relevant or irrelevant. But attention seems to enhance only task-relevant feature. So how can we reconcile these two? So the experiment is like this. So the same one, and the task target is paired with particular direction that is same with the previous. However, one task target is paired with the suprathreshold motion. The other task target is paired with the subthreshold motion. So this is the trick of new experiment. And here we found out the task irrelevant and subliminal or parathreshold feature are learned. But the VPL was suppressed when the task irrelevant stimulus was suprathreshold. So the attention suppresses task irrelevant VPL of suprathreshold motion. So it became so complicated. So let me summarize. So with the reinforcement signals, so task irrelevant feature as well as task irrelevant feature are facilitated. So the task irrelevant perceptual learning occurs when the stimulus was paired with the reward. However, attention suppresses the task relevant feature and facilitates task relevant feature. So the task relevant perceptual learning occurs only with, of course, task relevant feature. So the VPL seems to be controlled by this attention reward in a complementary modes. Okay, so this is the conclusion drawn on 2010. But recently, so that we are wondering how the perceptual learning with artificial stimuli, which that never exists in the natural scene or daily life, is different from perceptual learning in the natural scenes or daily life. So we thought we need some systematic investigation here. So we started with the task irrelevant perceptual learning. And as we know, the task irrelevant perceptual learning does not occur with the suprathreshold motion, right? Or suprathreshold stimuli. Or how is about the suprathreshold natural scenes? So the task is like this. So main task is still RSVP task, and the task irrelevant stimuli. So not here natural scenes were presented as task irrelevant stimuli on the background. And our question is, okay, so the natural scene contains some dominant orientation, and whether the task irrelevant perceptual learning occurs with this dominant orientation. So we compared 3 different stimuli. So that we used first task the natural scenes, and we did the Fourier transformation and the phase scramble. Now we have the Fourier scrambled stimulus. So this has the same orientation profile and same frequency profile, but meaningless and completely random. So we call also the artificial stimulus. And another way to make the stimulus is the Porter-Simon-Chair algorithm stimulus. So we call it the PS statistics. So this preserves the orientation and the frequency structure, and also the higher order structure of the natural scene, but still meaningless. So if you see these natural scenes and PS statistics on the peripheral, you may not be able to tell one from the other. So these are very similar in terms of the higher order statistics. And here is the result. So that we found task irrelevant perceptual learning with suprathreshold stimulus with natural scenes and the PS statistics, but not with the Fourier transformation stimulus. And of course, no the learning occurred untrained orientation. So previously with the artificial stimuli, so the attention suppressed, task irrelevant and suprathreshold, the task irrelevant VPL with the suprathreshold stimulus, but now it's not the case. So this is still ongoing study, so we are not sure why it happens. So to wrap up, so let me show some open questions. So what are the roles of attention and consciousness in task-relevant BPL? So attention and consciousness were rarely controlled in a separated manner in previous studies. So we still do not know which one is more dominant. The other one is why is task-relevant BPL based on supra-threshold natural scene stimuli possible? So higher order statistics contained in natural scene stimuli seems important, but it is due to failure of inhibition or facilitation of plasticity or something else. So we do not know. All right, so that's it. Thank you for your attention.
Okay, thank you, Kaz. So I believe we have a few minutes for some questions, and then we'll try to start Shufang on the half hour. Would anybody like to ask something?
Okay, maybe then I'll start then. Because about the relation with consciousness, I usually, or I mean, at least in some of the studies, your found effect of the learning is observed under the conscious condition, right? Like in the Takeo's seminal paper, yeah, the page 9.
Right.
Yeah.
So this is the testing phase.
Yeah,
so
testing
during
phase.
training, yeah, during
Right.
training, the subject cannot see any motion in a conscious manner.
But at the time of the expression, when the stimulus was presented in a conscious manner, then they can express what was learned.
Yes.
Is it generally the case under this, kind of framework of this perceptual learning? Do you always need to see things, at the time when you express what is learned?
I see. So it's a really difficult question. So in terms, excuse me. So in terms of visibility report or something, so so I don't think that sometimes the subject can show the better performance after training without having the clear visibility on the stimulus. So in this experiment, so they never tested the visibility or like the confidence on the task. So that it's all about the objective performance. But 5%, the 5% is clearly transferable, and for 5% they did some visibility testing. So the 5% are 5% none of the subjects said it's visible.
But that's only the conclusion for this particular experiment. But in general, people can demonstrate the learning under the invisible subthreshold kind of expression stage.
I see. So so I don't think the people are really tested that in the full detail. But for some supporting evidence is that the threshold itself can change a little bit.
Right.
Yeah. I mean, subliminal threshold can change as a result of training. So that suggests that I don't know. So the definition of the subthreshold, suprathreshold can change before and after the training. So
only on the trained part, it becomes improved in terms of threshold or the visibility. If that's the case, then yeah, that interacts with this. Basically.
Right. But I don't think it's really fully tested yet.
Okay.
Yeah, because if you are in this field, yeah, you of course tested that, right? But yeah, so usually people really focus on the performance itself rather than consciousness.
Is it possible the degrees will influence the training effect, the transfer effect? For example, if we can say the 45 degrees, there is a larger performance. If it is about 20 degrees, it may be significantly above the others.
Mm. Sure.
Is it possible that the people will like learn some degrees as a category? They will transfer the trained knowledge to the stimuli belong to the same category.
Yeah, that's really a good question. And Takeo tested that in 2018 or so. So if the category learning occurred before the visual perceptual learning, the perceptual learning transfers within category, but not between categories.
Yes.
So it facilitates, yes, the transfer.
Yeah.
No.
Should I ask one more question? Or okay, so or somebody raise a hand, so maybe I'll leave it. David, go ahead.
Hi, really great, interesting talk, and a lot to think about. I was just wondering if you believe there's a distinction between unconscious learning when a stimulus is very weak and unattended versus unconscious learning when the stimulus would be visible if it weren't actively being suppressed by something like continuous flash suppression. Whether there are similar mechanisms or whether you believe that there are different mechanisms associated with each type of unconscious learning.
Right. So the inattention learning and the sub-threshold learning. I see.
It's not just so for example, the old Watanabe and Sasaki studies and the precise ones, people are learning from a stimulus which is not being suppressed. It's just that the coherent motion is too weak to be perceived consciously, even when the stimulus itself is perfectly visible. That's different from the later CITES paper where they actively suppressed Gabor patches with continuous flash suppression.
Right. Yeah. So, I have no idea at this point. So so in terms of the the amount of learning and the amount of transfer are very similar among these studies, but internal workings may be different. So probably we need some imaging studies at this point. So there is no imaging studies on these experiments yet.
Yeah, just to follow up what David asked also. What's the sort of the status of the learning literature on the different kind of the unconscious states? For example, like anesthesia or deep sleep and so on. Does the different kind of unconsciousness qualitatively also results in different types of learning? Do you know?
So obviously, when people is sleeping, so vision cannot be done. Visual learning cannot be done. But in the haptic learning, so the task irrelevant learning occurs even when the people are sleeping.
In a way, like a tuning curve wise, similar like this way?
Yes. Yeah. Right. So the results are very similar, at least behavior.
I know that the people usually say that we can't present the visual stimuli during sleep, but there are some ways to present that actually, like with a goggle, and also to present like some kind of low spatial frequency stimulus is definitely possible to present with the goggle. Yeah.
I see. Maybe contrast sensitivity can be modulated during the sleep.
It's totally plausible, I think. Yeah. Although I don't want to be a subject for that.
Right.
Yeah.
Yeah. In the visual domain, I don't think someone has been doing this. Yeah.
Okay. And the other thing that I wanted to ask was that whether somebody tried to do this this type of study on the effects of the appearance or similarity structure, like before and after particular perceptual learning? Has anybody tried to characterize the perceptual sort of structure?
I see. So, right. So in terms of the transfer, they tested how the training on the one orientation transfers to the other. So this is very, very indirect to you, the indirect way to answer your question. So I don't think they never tested the similarity matrix before and after.
The only relevant thing is probably Tononi's stuff, but I think that's a bit different as well. Okay, thank you.
Oh yeah, thanks.
That brings us, I think, nicely to the end of the discussion part of our first talk. I'll hand it over to Chui. You want to introduce our next speaker?
Yeah, our second speaker will be Qiufang Fu, a kind and warm and helpful supervisor of mine. And Qiufang Fu is a professor at the Institute of Psychology, Chinese Academy of Science. And she has been the principal investigator of multiple grants from the National Natural Science Foundation of China. Her research interests focus on implicit learning, cross-modal learning, category learning, unconscious knowledge, and subliminal perception. Today, she's gonna share with us her work about consciousness and implicit learning. So I will leave this time and slide to Qiufang. Please go ahead.
Thank you, Chui. I'm very happy to have this opportunity to share my work with all of you. I just changed the title. The new title is Sequence Learning and Conscious Awareness. Many human skills like speaking, piano playing, driving based on knowledge about a regular sequence of events or actions. A fundamental function of learning is to acquire sequential structure in the environment. So can learning occur implicitly or unconsciously? I remember in one conference, Axel Clearmans had asked all people, does unconscious cognition exist? And some authors or some researchers insisted all cognition, all learning are explicit, but some others will argue there are unconscious cognition or unconscious learning. Serial reaction task, or SRT, is a widely used implicit learning paradigm. In this paradigm, participants responded to one of the 4 locations by press a button corresponded to the location, and the results showed when the location sequence was randomly, people responded slowly than when the sequence is sequentially. That is, the sequence followed a repeating sequence. Importantly, even the patients had the same learning effect, although the patients had a poor explicit memory. That means the learning occurred implicitly or unconsciously. Can people implicitly learn abstract structure of the sequence? Although there are many studies investigate whether learning can occur implicitly or unconsciously, but less authors are interested in whether people can learn abstract structure in sequence learning. This paper addressed this problem by using a serial naming task. That is, when participants saw an object, they needed to report what is the object, like a bat, rabbit, sock, like this. Unbeknownst to participants, the category sequence followed a repeating sequence, and sometimes the sequence became random category sequence. The results revealed when the category sequence followed a repeating sequence, the reaction times was much faster than the sequence was randomly. All the three experiments showed the same results. Importantly, participants reported they didn't find the category followed a sequence. That indicated people acquired the category sequence unconsciously or implicitly. Can people learn chunking and abstract knowledge at the same time in sequence learning? We recently we did this study by using SOC structure. In the SOC sequence, the previous two will determine the third stimuli. That is, the SOC 1 and the SOC 2 both followed the SOC sequences. The sequence are balanced on the stimuli frequency, the transitional frequency, and only one reversal in one SOC sequence. However, there is another possibility. For example, after 3 and 4 in SOC 1, the third one is 2, but in SOC 2, the third one is 1. There is another possibility. That is, after 3 and 4, there is another 3. The location could be 3. So we explored whether people just learn the statistical knowledge or whether people can acquire the abstract structure, because 3, 4, 3 consisted of ABA structure, and the other two are AB not A structure. So we ranged the standard and transfer followed either SOC 1 or SOC 2. They differed at the occurrence of probability, one with a big probability, the other with a small probability. The third one didn't follow the two SOC sequences. They had the different abstract structure with the transfer deviant, with the transfer stimuli, but they both occurred with a same probability. If people just learned the occur probability of the stimuli, there would be no differences between transfer and deviant. In the testing phase, we used a generating task to test whether people acquire explicit knowledge. The results showed people responded to standard faster than to the transfer. The standard and transfer had the same abstract structure, but occurred with different probability. That means people can acquire the concrete frequency of the triplets. Importantly, we found people responded to transfer much faster than deviant. That means people acquired the abstract structure in the implicit learning. The explicit test performance showed people had some explicit knowledge about the transfer and the deviant difference, but people had the similar performance for standard and transfer. That means the chunking or concrete knowledge about the sequence is implicit, but the abstract knowledge is explicit. When the training account of the blocks was shortened to 6 blocks, we also found the similar results in the training phase and in the test phase. To explain how people could simultaneously learn the chunking knowledge and abstract knowledge, we provided a de-dual SN model to explain these processes. We thought there should be 2 SRNs. One SRN was to process the abstract properties of the stimuli and will give the prediction about the abstract property of the next stimuli. The other chunking SRN will process the concrete properties of the stimuli and give the prediction of the concrete property of the next stimuli. The response layer will integrate the 2 predictions and give the exact prediction of the next stimuli. And the contribution of each SRN should be balanced for each prediction or for each situation. This is the Hellman performance. This is the model performance. We found only burst chunking SRN and the abstract SRN give the predictions. The results was more similar as the Hellman performance, but if only the abstract SRN works or only the chunking SRN works, there should be no the model has learned one type of knowledge. This is not similar to the Hellman performance. Moreover, we found when we differ the contribution of each SRN, we can model the explicit performance in the explicit test of the Hellman performance. So what are the neural indicator of conscious or unconscious knowledge in sequence learning? We used the PDP measure to dissociate explicit knowledge from non-explicit knowledge. We found a larger N2 effect for the acquisition of explicit knowledge and a larger PC effect for the acquisition of conscious knowledge. But if we just based on the learning effects in the training phase to dissociate procedure knowledge and no procedure knowledge, we found only a larger N2 effect for the acquisition of procedure knowledge. The behavior evidence also showed when there is procedure knowledge, there no explicit knowledge. So the N2 effect may be related to the acquisition of implicit knowledge rather than explicit knowledge. A recent meta-analysis study showed for sequence learning, the right basal ganglia is related to the acquisition of implicit knowledge. They used 3 methods to determine what are the neural correlates of implicit sequence learning, and the only brain area related to the acquisition of implicit knowledge is the right basal ganglia. So future studies for us, the future studies is the essential differences between what are the essential differences between conscious and unconscious knowledge. For example, whether implicit knowledge implicit knowledge can be transferred to the other situations, just like explicit knowledge. The second question is, what are the relationship between abstract processes and conscious awareness? Because some authors argue that all abstract processes occurred consciously, but we showed people could implicitly acquire abstract knowledge. The third question is, what are the neural correlates for conscious and unconscious processes in learning? This is a new question, and it is also an open question. Okay, that's all.
Okay, thank you, Qiufang, for the presentation. And now, is there any questions from the audience?
Okay, I can probably start if nobody has.
Please.
Then maybe a couple of probably clarification questions first for the audience also to who are not familiar with your work, prior work probably. Some of the acronyms like SOC, is that the sequence of category, for example?
Second condition, SOC.
What is SOC?
Second order conditional sequence.
Second order conditional, okay.
Like each position need to be determined by the previous two, not the one. Just the two. Yes.
Like 4-3 followed by 1, or 4-3 followed by 2, or something like that.
Yes. Only 3 couldn't determine the next one. Just the first 2, the previous 2, predetermine the third one.
Right. Okay, that understand. Yeah. And then when you talked about transfer versus standard in that structured learning.
Yeah.
Yeah. So that one.
Yeah.
Wait. Maybe 1 or 2 slides back.
This one.
One more.
This one.
Yeah, that one. This one. All right. So then, so you're saying that the probability that the next trial will follow the rule of SOC1 or SOC2 is like, I don't know, 90% SOC1 and 10% SOC2 or something like that?
Yes, like indeed in our each block, like 3-4, the 2 followed 3-4 occurred 10 times. The 1 followed 3-4 occurred 1 time, and the 3 followed 3-4 just 1 time. So 3 followed 3-4 with a big probability. 1 followed 3-4 with a small probability. 3 followed the 3-4 with a small probability.
And this larger probability sequence is the one that you're writing as a SOC1.
Yes, yes. For half participants, the trained SOC sequence is SOC1. For the other half, the trained sequence is SOC2. We balanced among the subjects.
Okay. All right. Then with respect to your last slide for the discussion, abstract knowledge and conscious awareness. So here you're saying that the abstract learning is the learning at the level of the sort of second order conditional structure of this task itself. Is that correct?
Yes, like the abstract process. Yeah, this is a very crucial one for our study. Like for the abstract processes, it's the difference between transfer and event. For transfer, like just one reversal triplet in the SOC sequence, like 3-4-2. The third one is different from the first one. But for event, the third one is same as the first one. So the structure is different between the transfer and the event. So we argue this is abstract processes because participants need to infer that after the 3, 4, there would be no or small probability the third one is same as the first one, like ABA structure.
I see. Okay. Then maybe I'll ask one more question. So
please.
What Kaz was talking in the beginning was, in a sense, sort of the simpler or sort of the easy to grasp for me, because I'm more on the sensory side of the person, and it's learning about what they saw or what they did in terms of task, right? And then here, your conscious and unconscious is about knowledge and the structure.
Yes, the relation between stimuli. It's not like the supraliminal perception or subliminal perception. The stimuli were consciously or were supraliminal pursued, but the relation between the stimuli were unknown. Like in the SRT task, participants needed to respond to each stimulus just as quickly and as accurately as possible. The relationship between the stimuli was unknown to the participants. They also needed to predict the next stimuli, because this is really very fast task. They need to continually respond to the stimulus.
Yeah. The kind of a common ground between this and the Kaz's talk would be probably the role of the reward and also a role of the attention, maybe. Do you guys have any kind of comments to each other's?
Yeah, like attention, because it's argued the implicit learning like SRT needs only minimal attention. Like the second task will not influence the implicit learning, but will influence explicit learning.
Just a bit question. So in this task, how do you control attention? How do you check the effect of attention on this implicit learning task?
Yeah, in this task, this is just one task, no the dual task. So we didn't check the role of attention. But in the testing phase, we will examine the role of consciousness in this task, like whether people acquire explicit knowledge in this training phase.
I see. So the sorry, go ahead.
No, I just say we might not be able to see that image very clearly, but I think it's this confidence report is the way to control the consciousness awareness.
Yes. Like the measurement of conscious knowledge is controversial, like objective measures, subjective measures. Yes, some people like you argue the confidence is like a weak one, like they maybe overestimate the unconscious knowledge, the role of unconscious knowledge. But we can say the generation performance in experiment 1, we have a very long training phase. So you can say the standard transfer standard really significantly greater than transfer, but there is significant differences between inclusion and exclusion for standard and for transfer. Because transfer occurred with a small probability, So in inclusion, they need to control the expression of transfer because they occurred with a small probability. But the results revealed participants generated more transfer triplets and inclusion than exclusion. That means participants treated transfer similar as the standard, so they couldn't distinguish standard from transfer and inclusion and exclusion. That means the probability, like the chunking, if the stimuli, because standard and transfer stimuli have the same abstract structure, they couldn't be distinguished by the participants.
Okay.
Yes, like the confidence is one method. We also use the PDP method to measure the role of the conscious in the learning.
Yeah, I also was going to ask also that what is a PDP?
Process dissociation procedure. Yes.
But maybe not all the audience knows about it. So can you briefly explain that?
Yeah. Inclusion test. In the inclusion test, participants were asked to generate the sequence similarly to the training phase, like what the next stimuli, what's the location, the next stimuli frequently followed the previous two. And in the exclusion test, participants were asked to the different question, like what's the next stimuli? Followed the previous. What's the next stimuli? The third. Sorry, I just like contrast to the inclusion test. The inclusion test asks frequently occurred one. The exclusion test asked to generate the stimuli rarely occurred in the training phase. So the instruction were opposite in inclusion and exclusion. So participants, if participants acquired the explicit knowledge, they will responded differently in inclusion and exclusion. So we used the difference between inclusion and exclusion to infer whether people acquire explicit knowledge or conscious knowledge in the training phase.
Okay.
Okay, I think there is a question from Julian.
Yes, thank you for the talk, Shufang. I was thinking a little bit about when I explicitly chunk things. I often find that the memories I associate with those things that I explicitly chunk seem to last for a very long time. I almost feel like I never forget them. I was curious if in your study or in subsequent studies, you've looked at how long these implicit chunking abilities remain for. Do they extinguish quite quickly or not? Do you know, or do you have a feeling?
Yeah, maybe the chunking is a misleading one concept in our study, because we used a SOC structure, like second order conditional structure. So the triplet is the chunk is limited to three. Just three. Actually, we analyzed how many chunks people really acquired, in how many triplets people could really acquire in the training phase. We found it's about 7 triplets. Generally, on average, people just acquired 7 triplets in the training phase.
That's curious. That's almost the working memory limits by some accounts. That's quite strange for implicit learning. Perhaps this is somewhat online. Yeah, cool.
Yes. In our 2010 paper, we have reported that results. Thank you.
Okay. Sorry, Julian, is there any further question? If not, I think there's another audience want to ask question. Daisuk. Sorry if I pronounce your name wrong.
Almost. I'm Daisuke. Thanks for the great two talks.
Thank you.
My understanding of today's two talks was they are mainly concerned about the contents of consciousness, like a particular stimulus is consciously visible or not. I was wondering about arousal or level of consciousness and how level of consciousness can impact learning. The reason I'm asking is that this kind of level of consciousness can fluctuate over time within an experimental session. And maybe a reward or tension could be associated with the level of consciousness.
I don't know whether I got your point. Do you want to know the role of consciousness in learning, in abstract learning? Or could you repeat your question?
Yeah, so my question is whether the level of consciousness within a trial, how it can impact the learning process in general.
You mean the differences between implicit learning and explicit learning? It's right?
I think what Daisuke wants to know is probably over the, let's say, you have a block, it's, I don't know, how many minutes you have in page 10, for example, if you go to page 10.
How many minutes? You mean in each block, how many minutes?
Yeah.
Like
let's say.
1 or 2, about less than 2 minutes.
Yeah,
Because
then probably
we have a short break.
Yeah, probably sometimes people are sleepy, sometimes people feel like more motivated, and that kind of fluctuation.
Yeah.
Of the arousal. Does it actually affect on the learning? Is that what Daisuke you want to ask?
Yeah.
Yeah. Yes, this you can say that it's the up and down. It's not like a linearly that will be influenced by the tiresome or the state of the participants. But we can say in each block, at first there's no differences between transfer and event, but then there is a dissociation between transfer and event, between standard and transfer. So this means because this is a relatively long experiment, it's 20 blocks, like about 40 minutes to complete the experiment. We didn't say the ideally linear line about the results, but we have the differences between standard and transfer, between transfer and event. This is really very clear.
Maybe, but the same question also to Kazu as well. I'm also curious about this because we have recently, worked on the mind wandering, and in our hands, also the mind wandering or mind blanking is related to the local sleep.
Yeah.
And your work with Takeo, or maybe you are not related, but Takeo is claiming that sleep is also related to learning, right?
Yes.
So if that's the case, maybe mind wandering and also perceptual learning or this kind of abstract learning can also interact, like Daisuke implies.
None of us checked the relationships of the levels of consciousness of the perceptual learning, but I am interested in the roles of the arousal in perceptual learning. So in a reward experiment and attention experiment, this can be explained just the transient changes in arousal. right? So that when what is given, or when task is given, so that your arousal can be transiently changed. So the both reward effect and attention effect can be explained merely by the transient changes in arousal. So if it is the case, so the at the time of reward or at the time of task target, the pupils can we could detect the changes in arousal with the pupil diameter.
Yeah, exactly.
Yeah, and if it is the case, if we and it is the obviously related to noradrenaline and the what was that, the LC, so the locus ceruleus, so the seihankaku, so the LC. So and I'm interested in that, so that I checked how to change manipulate the noradrenaline activity with psychophysics. So the one possible way is just changing the pupil diameter with the auditory stimuli. So that this is kind of the reverse inference. But I found one paper that tried to change the noradrenaline activity with psychophysics. And if it is the case, so the reward and attention should be correlated with the pupil diameter. And if we change the pupil diameter, the task-relevant perceptual learning occurs. But this is a very interesting experiment, but we haven't done that yet.
Okay, I have a question regarding this. I don't know about your task, Kazu, but I remember, I think Qiufang also collect EEG data while doing this sequential learning task.
Yeah.
Is that possible to calculate the level of, say, sleepiness or alertness based on those EEG data?
That's right.
Yeah. So I always use fMRI, so probably you found has a better idea.
Because me just one person visited my office, I didn't hear. Is it the question about my EEG data?
Yes. I remember you also collect EEG data while doing this task during this study. So I wonder if it's possible to calculate the sleepiness or alertness using that data.
Yes. Actually, the EEG data reveal that because after each block we had at least 30 seconds rest. So after the block, when one block was completed, there is the alpha waveform, and so participants really like have a rest in their brain like that. But during the task, because the task is continuously to respond to the stimuli, so there is no obvious patching of the rest like that.
Yeah,
I don't know if Daisuke still you are raising a hand to follow up a question, or
oh, sorry, I missed one.
If not, then
okay.
Yeah. So if you apply the slow wave detection algorithm that we have used in our paper, which I can send it to you later, then the magnitude of this slow wave is actually massively bigger compared to any of the event-related potentials by the visual stimuli or motor, command-related activity. So I think it's possible to quantify how frequent, this local sleep actually happened during each of the session, and then see whether that predicts the subsequent learning or performance or something like that. Yeah, if you are interested.
I'm interested, and in my lab there is a doctoral student also do the mind wandering study, and
I see.
Yeah, that's really very nice to hear that you are doing the same task.
I see. But we don't do any learning related mind wandering study so far. So yeah, you guys can already study that already. Yeah.
Yeah,
good.
Yes.
Yeah, so that I'd be interested in the consolidation and microsleep. So that my guess is that at the stage of encoding, so that lower consciousness hinders encoding. However, at the stage of the consolidation, the lower consciousness probably facilitate the consolidation. So recently, in the field of the motor learning, so one hot topic is the micro consolidation that occurs like inter-trial interval, like 5 seconds or so, just increasing the giving the small gap between two trials that facilitates the consolidation. So, and I wonder if the local sleep can occur if we allow them to just a bit break, 3 seconds or so. The brain turns into the micro sleep, stage, and during that stage, consolidation occurs. But if this is continues to the encoding phase, that may hinder the encoding or learning there. But yeah, so it's really fun experiment. Yeah.
That's a good idea, actually, and I think it's plausible. Do you know if like meditation or some kind of does meditation actually affect on the learning?
Oh yeah, so the Takeo's former postdoc so they did that meditation study during offline period after training. So that in her case, so that what she found is it's still vague, but so it was not the meditation during training. That was the after training phase, and that affected maybe so either degree of learning or the degree of the interference or protecting interference, or yes, some effect was there. But in any case, so sounds like the meditation, the effect of meditation is related to consolidation. Rather than
So what I was thinking is that maybe if you can control the sort of the occurrence of the local sleep intentionally through respiration or meditation or whatever, and if the local sleep is the sort of mechanical kind of link to facilitation of learning or consolidation, maybe if you just try to look at the effect of the meditation per se, maybe it's really unclear in terms of results. But for those who are actually able to increase the local sleep during this 5 seconds or something like that, maybe that's the case where learning may be facilitated.
Right.
That's possible.
So our lab just started EEG and started the motor experiment as well, and we just got the TMS. So maybe that we can facilitate the local the slow activity with TMS possibly. I don't know.
I see.
Yeah.
Start a little meditation corner in one end.
Right. Yeah. We need to be quiet.
Okay.
Okay. Any other questions, comments, general discussion?
Also, it's already in the general discussion part. Okay.
Yeah.
But yeah, I'm really impressed by the Nao's question about the relationships between different features after learning. So in the perceptual learning field, so that we rarely check the appearance before and after training, or the how can I say qualia or the impression of the stimuli before and after the task. So we only care the performance and its transfer. So I wonder what happens so that like Sapir-Whorf hypothesis. So that our language or appearance comes from the culture. Our perception comes from the culture. So that if the perceptual learning training asks you to see or distinguish the particular small subset of the subset of the whole feature structure, that makes the huge impact on the appearance or the subjective experience of these features. But that if the Fourier structure that kind of hypothesis is true, that should affect the whole structure of the feature space, right?
Yeah, so I guess that's naturally expected, but whether anybody tried to study that, at least in adults, maybe it's a bit difficult, but somehow these kind of things should be happening when children or babies are learning various concepts, various types of the perception, right? And whether this type of learning, I mean, learning study in adults are very difficult to do with this type of things that affects directly on the appearance, maybe. Yeah, but that's a interesting question, I think, and the fundamental of all. The question of consciousness and learning.
Right. So the most trivial result is okay. So the appearance changes just around the trend feature. But if your theory have some interesting prediction, like in the space, let's say the color is in the circle space, right? So that if you are trained with the red color, that can affect the opposite, I don't know, green color perception or so. If you can make the specific prediction based on the hypothesis, that would be very interesting test. If you use the learning paradigm, yeah.
Yeah. So, for example, the Takeo's paradigm, right? If if you believe some philosophers, like Rosenthal and other people who consider these both non-concept and non-conscious and conscious quality space are the source of this, conscious similarity rating and so on. And if you train only one particular direction to be, sensitive, then it should disrupt or sort of modify at least, the quality space of many different directions. So the similarity relationship among many different directions should change before and after the learning of a particular direction.
I see.
But so you're saying that nobody has done that, right? Most likely.
No. Yeah. No.
Yeah, that's good to know. Yeah. Although it's probably very difficult task to try.
So at least regarding the performance, so the performance improvement almost certainly occurs with 10 days training. So this is just about performance, but I'm curious how the appearance changed. To me, I have been trained with the motion, the moving dots for like 20 years, but I don't think that my motion perception greatly changed. But not sure what it means. Yeah,
it will be very subtle, I would say. You can also train some of the domain of the things in one particular location and then see how the stimulus appears similar or dissimilar between, let's say, phobia and that particular location.
Right.
That may be relatively easier to test, possibly. And if it's only 10 days to induce such a change, maybe it's relatively, feasible to try as well.
Right.
And do you both have any kind of, cross kind of a fertilizing question between the conceptual or semantic or abstract knowledge type conscious unconscious versus sensory type conscious non-conscious? Kui-fan and so Kazu? maybe these two fields probably don't talk to each other in the normal conference, right?
Yeah.
Probably.
I kind of have the same feeling. I say Kazuhisa is perceptual learning and Qiufang says abstract knowledge. I have a feeling that this might be some overlap between these two terms. But
yeah, like yes, I'm really interested in one question about the perceptual learning, like whether people acquire like just exact or abstract knowledge in perceptual learning. Because when we write one paper about multisensory category learning, we found the learning effects can generalize to untrained stimuli. But when we like read the references on perceptual learning, like most findings were limited to the trained direction, like what you have showed. So is it possible, like a category learning is obviously category learning acquired the abstract structure about the category, but the perceptual learning will be limited to the concrete knowledge. But also, like in my sequence learning, we found that people will like have abstract processes in each task. So maybe perceptual learning also include some abstract processes. Just the test is not so sensitive to find the abstract performance, abstract transfer like that.
Sure. So the Professor Konyu in Peking University, so he has been arguing that all perceptual learning is abstract learning. So yeah, we are not obviously in line with the proposal, but according to him, so the perceptual learning is abstract learning. So that in his experiment with some very interesting twist in the training regimen, so the perceptual learning indeed transfers to all the locations or all the feature space just with the one training. So the according to him, so that with the perceptual learning, we learn something very abstract. Like orientation is not the grading or like the very specific knowledge, but abstract knowledge of the orientation. So that the people are good at the discriminating orientation anywhere in the visual field and any angle. So it's still the hot or very controversial field in that aspect. But what we think is that so there are different mechanisms. So in perceptual learning, so there is no unified the way or mechanism to explain everything. So it always becomes divergent. So in the Takeo's experiment, it's purely, exposure based. So there is no chance to develop abstract knowledge with it. So there might be different stages or mechanisms for that. So yeah, so answering your question or the comment, so the perceptual learning also thinks, the perceptual learning field also thinks that abstract mechanisms as well. But not integrated in the with it. Yeah.
Yeah.
Oh, so probably the comment on the sequential learning field. So in the perceptual learning field, so that we try to tell or dissociate the cause and effect. So during the training phase, we try to make it explicit, so the subject know what is learned, or sometimes implicit, so that as in the exposure learning. So this is probably the cause of learning. And in the sequence learning, so that you talked about the probably effect of learning. So as a result of training, the subject get the explicit knowledge or implicit knowledge. So this is, I guess, the effect of training. So is there any way to make a separation between explicit training and implicit training?
Yes, actually, in previous studies, there are some works like using manipulated instructions to make the participants in implicit learning group and the explicit learning group. Like in the implicit learning group, participants were not instructed to the stimulus location followed a sequence. But in the explicit learning group, participants were taught that you needed to find the rule or the sequence regularity to facilitate your learning effect like that. Generally, the learning effect in RT in reaction times are not different, but the explicit knowledge had were different between the two groups. Also, there is one possible like solution about the dissociation between implicit and explicit. For example, if there is a P3 effects occurred in the learning effects, that might be indicated participants acquired explicit knowledge in the training phase. Also, another possibility is whether there is a RT drop, like dramatically drop, just at during the training phase, the RT suddenly drops very much, and then like people might acquire explicit knowledge.
I see. So is there any differences between the learning outcome between explicit and implicit? So you say the reaction time change are similar.
RTs, yeah.
RTs, but how about the like transfer effect or any other effect? So that if there is no differences, so that I wonder what is the role of consciousness in learning?
Yeah, I thought maybe it depends on the complexity of the rule. For example, in 2010, like Michel Hose in German, they found like Hader, they found they used a very simple regularity, like just 6% of a sequence, 6 elements of a sequence. And if participants acquired the sequence, then they found just a dramatic drop of the RTs. Also, there is like the different neural correlates of the related to the RT drop. So they also like suggested I have hypothesis about explicit the occurrence of explicit learning or explicit processes.
Yeah. So as to Kazu's comment on the function of consciousness on learning, I think most of the problem with respect to this kind of question is also it's limited or restricted by the paradigm that you guys use it as well, right? Like in the case of perceptual learning, you need lots of repetition from the beginning, and also for this type of reaction time experiment, you also need lots of trials to see the effects of the learning. But my guess of most of the benefits or specific kind of thing that you cannot do without consciousness in the field of learning is that it's a really complex and so one-shot type of learning, right? That's it's very difficult to quantify, but most likely without really understanding at the abstract level, and also without seeing consciously, like under the continuous flash suppression, I don't think you can learn anything about new concepts on, let's say, physics or category theory or linguistic or whatever. It's gonna be difficult to measure, but that kind of measure is probably necessary to uncover or address or evaluate the role of consciousness in learning in its sort of quite natural ecological validity.
Yes,
that's my guess.
yes, I agree. Just I want to say, like, conscious learning and unconscious learning can progress in parallel, and they can also compete and interact with each other. So they use different strategy to learning to determine our behavior, but they also can interact with each other. So I just recently I found a very interesting impression. For example, I just saw a person. I saw the person is my colleague, but then I saw whether he is my colleague. I will saw his what he wear and his height and his the back of his head. And then I thought maybe he is not my colleague. First is unconscious processing told me he is my colleague. That's the holistically told me. I didn't know why why my brain told me he is my colleague. But then I used my conscious analytic reasoning system to refer whether he is my colleague, and I concluded a different. I found it difficulty to get a conclusion, but it's like the conscious processes and unconscious processes, how to determine our behavior or how to determine our decision, like that.
Okay. Before this goes any further, I want to remind you it's already 90 minutes. So is there any final questions or comments from other audience? And if not, you can continue this discussion. Okay. So if no questions from other audience, please go ahead. Sorry for the interruption.
Yeah, maybe we can then wrap up as well. Yeah, thanks Kazu and also Q-Fan for the extended discussion.
Thank you so much.
Thank you.
Thank you.
And also Julian and also Jane for the host. Thanks a lot.
Yeah, thanks.
Bye-bye.
Bye-bye.